Haley is making a box for a project from a cardboard piece with a length of 66 and a width of 42. To start this problem off, we'll be drawing a rectangle so we can visualize the problem. And then we will be labeling the length and the width so we have everything in check. After that, we'll draw a 3D rectangle or a cube so we can see what the box will look like when we are finished with it. Now, I labeled these, but it is better if you don't do that because this will end up changing because with the rectangle, you take off each corner, so it will not be 66 by 42, but that will be cleared up later. Anyway, next is the equation. So the equation will be x, which is the height, and then length, which is 66 minus 2x, and then the width, which will be 42 minus 2x, because of those corners, you got to take out 2 x's. After that, you're going to plug everything into Desmos, so it'll give you the shape. Now, as you notice that this is outlined in red and is called fake. That is because that number comes after the 21, 0, or the x-intercept. And after it hits 0, you have an imaginary box. So everything before that, which is highlighted in green and labeled real, or everything at this point, is a real box. Now, another way you can do this is that 21 is half of the lowest number, which is 42. So you could just go to the lowest number and just divide it by 2, and that'll get the same thing. Next, you have the domain, which is 0 is less than x is less than 21, because you can't have a number bigger than 21 without it being imaginary. Now we're going back into Desmos and finding the height of the curve, which is 8.356. And I will be plugging that in to the x part. So it would be 42 minus 2 times 8.356, which gets us 25.288. And then we'll do the exact same thing with 66, doing them 2 times 8.356, which gets us 49.288. Then what we'll do is we'll plug in both of those numbers we got for those answers into it to find the volume, along with 8.356, because that is the height. This results in the answer of 10,414, which is the volume. We're going to finish this off by putting in the max height, which again is 8.356. And then we'll be doing the max volume, which again is 10,414 plus the 0.88. And then you're done. And that is how you find the max volume of a box.